This lesson is on combining functions symbolically, which is what we really want to understand, and graphically, which is what we learn to help us understand why we're doing what we're doing symbolically. And speaking of symbols, here's a bunch of symbols. Adding and subtracting. If you're given two functions, f and g, then you can add those two functions together. Symbolically, it would look like that. This just means you're adding f and g, the input is x. It's equal to finding f of x and g of x and adding them together. So this means that difference of f and g is to find f minus g of x is equal to f of x minus g of x. The domain of the sum and difference of a function that you create is the intersection of the domain of each. So if you find the domain of f and then you find the domain of g, the domain of the sum and the difference has to take both of those into account. It's the intersection. So if you've got the restriction in this one, then it's going to be a restriction of the whole thing. So I'll explain. Alright, so the first thing we're going to look at, example 1, we have two different representations of the function. First function f is given symbolically. It's equal to 2x plus 3, which happens to be a line. And the second function g is just 1, 2, 3, 4, 5 specific ordered pairs. So the domain of f plus g and f minus g. Well, the domain of f, that's a line, so there's no restrictions on x. It's not in the denominator, and there is no radical. So, and you know it's a line, so the domain is negative infinity to infinity. The domain of g, however, is very specific. It's explicitly stated. It's only the x coordinates negative 2, 0, 1, 3, and 5, and that's it. So the domain of the sum and difference function would be the intersection between these two, or just the restrictions, and one of them is going to be a restriction to the whole thing. So if this is domain of everything, all the numbers in the world, but this is only these 5 specific numbers, then the domain of f plus g and the domain of f minus g is also going to be restricted down to just these 5 numbers. Okay, so how do you compute f plus g and f minus g? Well, first of all, the domain is very explicit, so we know we're only going to have these x coordinates. Okay, f of x is symbolically defined, so the way you find the outputs with these x coordinates is you plug the x coordinates in for x, and your output is your y coordinates. So we will do that. So f of negative 2 is equal to 2 times negative 2 plus 3, so that's negative 1. F of 0 is equal to 3. F of 1 is equal to 5. F of 3, 2 times 3 is 6 plus 3 is 9. F of 5, 2 times 5 is 10 plus 3 is 13. Okay, so make sure that's right. Okay, so now g of x, we've got the table of outputs. So when x is negative 2, g of x is 0. When x is 0, g of x is 3, so forth and so on. Alright, so to find the sum of f and g of x, well, we already know these are our inputs, so all we have to do is just add the y coordinates. This is f of x, this is g of x. So negative 1 plus 0 is negative 1, 3 plus 3 is 6, 5 plus 4 is 9, 9 plus 5 is 14, 13 plus 16 is 19. To find f minus g of x, that's the same as f of x minus g of x, so we'll subtract the y coordinates. Negative 1 minus 0 is negative 1. 3 minus 3 is 0. 5 minus 4 is 1. 9 minus 5 is 4. 13 minus 6 is 7. Okay, so the next one, a little bit more what you would have. You're given two functions. F of x equals x squared plus 1, and it might help you to think, oh, that's a parabola, that's a quadratic. And g of x is a radical function. And notice that x is under a radical. This is an even index. There's going to be restrictions. This is what a radical function looks like. So what happens when you add a quadratic function and a radical function? All right, well, we want to find the domain. So the domain of f, there's no restrictions on x. Is x under a radical? No. Is x in a denominator? No. So you can put any number in the universe in for x. If you know it looks like this, also it shows you that x is anything, negative infinity to infinity. The domain of g, however, we have a restriction. You have to always carry that knowledge about the domain restrictions with you everywhere you go in this class. So this domain, remember, if you have a radical with an even index, you set what's under the radical and you have it memorized. This has to be greater than or equal to 0. So if you add 2 to both sides, you get that this domain is from 2 to infinity. So there's a restriction on this domain. And so the intersection, that just means if it's a restriction here, then it's going to be a restriction in the domain of f plus g or f minus g. So all real numbers domain, but then here it's just from 2 to infinity. So the new function you create is just going to have a domain from bracket 2 to infinity. Okay, so now let's compute that. So f plus g, it just simply means to add those two functions together. Okay, so f of x plus g of x simply means add x squared plus 1 and the square root of x minus 2. And what you've done is you've created a new function. Okay, so this new function, sometimes people don't want to stop here. They think they have to solve for x. What you're doing is creating a new function. So what I thought I'd do is graph this new function. I'll call it, I don't know, k of x. And it is x squared plus 1, and that looks like a parabola like we thought, plus the square root sqrt of x minus 2. And when you look at that, that's not something that I would have guessed it would look like. It gets a little harder to kind of guess what these functions are going to look like, but this seems to have a curve here, and then it starts to look a little bit more curved up. But look at the domain. The domain is from bracket 2 to infinity. So that's what we thought. So you're done. This is it. This is your new function, and it has this domain. If we want to find f of x minus g of x, that would just be f of x minus g of x. And resist the urge. Understand what you're doing. You're creating two new functions that are weird. And that's it. There's no like terms to add or subtract. So that's it. Okay, so example 2, let the dashed red line represent f. So this is not color, so this is f of x, the dashed line, and then the solid line is g of x. Write the domain of f plus g using interval notation. Well, the domain for this one's pretty straightforward because this is a straight line and that's a straight line. They're x's are going to go on forever and ever, so the domain is just all real numbers. All right, and now we want to actually graph f plus g. So we're going to expand this. Here we were given explicit x coordinates. Here we're just given some lines. So what we want to do is just pick some x coordinates, and I only have room for 3 here, so we'll just pick a positive, an x coordinate, a 0, and maybe a negative, a 0, and a positive x coordinate. So maybe I'll pick -2 and 0 and 4. Just randomly pick those x coordinates. Alright, now I've been known to make errors here, so just try to concentrate on one function at a time. So let's just look at the f. When x is -2, f is, it seems to be 1.5, we'll say. And when x is 0, f is 1. And when x is 4, f is 0. Alright, now try to just focus on this solid line. When x is -2, g is -2. And when x is 0, g is -1. And when x is 4, g is 1. Okay, and we want to find f plus g of x. That's the same as f of x plus g of x symbolically. So we're just going to add our y coordinates. 1.5 minus 2 is -0.5. 1 plus -1 is 0, and 0 plus 1 is 1. So now what we want to do is graph the ordered pairs. Here's your x coordinates, and here's your y coordinates that you're going to graph. So -2, -0.5 would be about right here. 0, 0 would be right here. And 4, 1 would be right here. And then you can just connect the dots, because these 3 ordered pairs just represent the 3 points that you're using to graph. And I knew it was going to be a line, because when you add a line and another line, this is where symbolically it might be helpful to see. So like if you have a line, let's say this looks, I don't know what it is, let's call it h of x, so we don't think x plus 4, and then k of x is like, let's make it -x plus 4, 2x plus 3. We haven't learned about degrees, but if you notice that if you add these together, -x plus x is x, and then 4 plus 3 is 7. So you get another line because you don't have a different degree. It's the same degree. So your result is going to be the same type of graph. You can memorize the sum of 2 lines is a line. And then you might want to notice this. This is a negative slope because it's decreasing, and this is a positive slope because it's increasing from left to right. Notice that this is a little steeper than this one, so that's why your result is still an increasing line, but the slope is less steep. Okay, so if we want to do the same thing for f minus g, same thing. I'm going to it's the same line, so I'm going to steal these points. -2, 0, 4, 1.510, and -2, -1, 1. Alright, so f minus g means f of x minus g of x. We know the domain is all real numbers. And now we're going to subtract, so we have to worry about this minus. So 1.5 minus a -2 is the same thing as 1.5 plus 2, so that's 3.5. 1 minus a -1 is 2, and 0 minus 1 is -1. So we'll graph these ordered pairs here. -2, 3.5, 0, 2, and 4, -1. And the difference of 2 lines is going to be another line. Okay, so what happens when you have a quadratic? So that's an x squared and a line. Okay, so these have two different degrees. They're different types of functions. All right, well, you can do the same thing. Again, we want to let the little dashed line be f of x and the solid line be g of x, and we want to pick, you can pick more than 3 points if you want. I'm just going to pick 3, and I'm just going to pick a negative, a 0, and a positive. So I'll pick negative 2, 0, and 2. And I'm going to try to concentrate just on f of x so I don't get confused. And so when x is negative 2, that looks like 5. And when x is 0, that's 1. And when x is 2, also 5. Okay, so if we then look at g of x, when x is negative 2, y is negative 2. And when x is 0, y is 0. And when x is 2, y is 2. Okay, so if we want to find f plus g of x, that's the same thing as adding f of x plus g of x. So f of negative 2 is 5 plus a negative 2. 5 plus negative 2 is 3. 1 plus 0 is 1. 5 plus 2 is 7. So these are my ordered pairs. All right, let's graph that. So we have negative 2, 3, 0, 1, and 2, 7. Okay, so this is obviously not a line. Well, what is it? Well, kind of have to do the symbolic. So I think I know exactly what these graphs equations are. So this is y equals x squared plus 1. I mean, f of x equals x squared plus 1. And this one is our friend y equals x, or g of x equals x. So if we add these together, you can't add x squared plus x. They're not like terms. So you just have to collect all of these unlike terms, and I'll put it in descending order. So f plus g of x is x squared plus x plus 1. And because it's an x squared, that is a quadratic. So that tells me that this result is going to be some sort of parabola. Now, I'm not real sure where the vertex is. That's beyond where we are right now, so I'm not worried about that. But the result of a quadratic and a line is going to take on the degree, x squared degree. So we have that. Didn't do the domain because this is a pretty trivial domain. This is all real numbers. That's all real numbers. So the domain of f plus g and f minus g is negative infinity to infinity. All right, if we want to graph f minus g, same graph, so I'll go ahead and just copy this down. All right, but this time we're doing f of x minus g of x, so we have to pay attention to this minus. So 5 minus a negative 2 is actually 7. 1 minus 0 is 1, and 5 minus 2 is 3. So we have negative 2, 7. 0, 1, and 2, 3. And same thing as before. This is a degree 2. It's an x squared, and this is an x. So when you have x squared plus 1 minus x, that's going to leave you with x squared minus x plus 1. So this is what f minus g of x is. This new function, it's going to be a parabola. And so the idea of this graphing is just to really get you to understand that when you add two functions, you're not solving for x. We got to move beyond that. That's pre-algebra. That's algebra. That's all you did. Now we're creating new functions. So f of x plus g of x created this new parabola that got slid over just a little bit. F of x minus g of x created this new parabola that got slid over just a little bit. That's what it looks symbolically. x squared plus 1, this function, minus that function created that function. So don't go and try to solve for x. Alright, what happens when you have two parabolas? What's going to happen? Well, if you know the degree here is 2, the degree here is 2, you know, what is going to happen? We'll see. Okay, so we're counting by ones, so I'm just going to pick, only have room for 3. These tables are for your convenience. You may not have those on the test, so you just pick as many ordered pairs as you need. I'm going to pick -1, 0, and 1 as my x coordinates. If you need to pick more, you can. Then I'm going to, let's see, let's let this one here be, the dashed one here be f of x, and the solid one be g of x. Okay, so f of x, when x is -1, we have 0. And when x is 0, we have -1. And when x is 1, we have 0. And g of x, which is this one, when x is -1, we have 3. And when x is 0, we have 4. And when x is 1, we have 3. Okay, we know the domain of this goes on forever and ever, and that goes on forever. There are no restrictions on the x-coordinates. On x-axis, x can be anything. So the domain of f minus g is going to be -infinity to infinity. All right, now let's find f minus g. So we will take these y coordinates because f minus g of x is the same thing as f of x minus g of x. So 0 minus 3 is -3. -1 minus 4 is -5. 0 minus 3 is -3. And we have these points. So we'll graph -1, -3, 0, -5, and 1, -3. Okay, so it does not look like it is a line. It looks like the result is a quadratic. And if I had to guess what these, I can tell what these are. So f of x was positive x squared minus 1, and this is negative x squared plus 4. Okay, so if I subtract these two, you've got to be very careful. F of x minus g of x, let's use parentheses, is x squared minus 1 minus parentheses negative x squared plus 4. So if I distribute the negative, I get a positive x squared and a negative 4. And I end up with 1x squared plus 1x squared is 2x squared, and then minus 5. So there it is, there's a parabola. Now if I were to add these two, I may not get a parabola, because if I were to add these two, just look, I'm not going to do it. What happens to this? X squared plus a negative x squared goes 0. -1 plus 4 is 3. So actually if I were to add these two, I would get just a horizontal line right through y equals 3. So that's interesting. We're just creating new functions. And the other idea is that the domain of f and the domain of g, the intersection of those domains is the domain of f plus g or f minus g.